Ever wondered why your body temperature stays around 98.6 degrees Fahrenheit even when it's freezing outside? Welcome to the world of homeostasis. Homeostasis, a term coined by Walter Cannon, is the body's self-regulating process that works tirelessly to maintain a stable internal environment no matter what's happening externally. Imagine your body as a house and homeostasis as its thermostat. The thermostat's job is to keep the house at a comfortable temperature. When it gets too hot, it triggers the air conditioning to cool things down. When it gets too cold, the heating kicks in to warm things up. Similarly, homeostasis regulates your body's internal environment. For instance, when you exercise and your body temperature rises, homeostasis triggers sweating to cool you down. Conversely, when it's cold, it prompts shivering to generate heat. So, in simple terms, homeostasis is your body's internal thermostat that keeps everything in balance. But what happens when this internal thermostat goes awry? Well, that's when things can get a bit dicey. When homeostasis fails, our bodies can no longer maintain that fine balance, which can result in illness or disease. Take, for instance, dehydration. Our bodies need a certain amount of water to function properly. If you don't drink enough, your body's water balance is thrown off. This can lead to symptoms like dry mouth, fatigue, and even confusion. Or consider hypothermia. If your body temperature drops too low, your body can't effectively carry out its functions, leading to symptoms like shivering, slow breathing, and possibly even loss of consciousness. And then there's diabetes, a condition that occurs when your body can't regulate sugar levels in your blood. This can lead to a host of complications from nerve damage to heart disease. Thus, when homeostasis fails, it can lead to some serious health issues. Now you may wonder, how does this internal thermostat work? Let's break it down. Every control system has three main components: the receptor, the control center, and the effector. Think of it like your home's heating system. The receptor is like the thermostat sensing the temperature. The control center, akin to the thermostat's programming, decides what to do. The effector, like your furnace, carries out the commands. So that's how your body's control system works to maintain homeostasis. This control system can function in different ways. Picture local control as a neighborhood watch keeping an eye on the immediate environment. Long-distance control, on the other hand, is like a country's defense system, monitoring and reacting to distant threats. Reflex control? Think of it as an automatic response to a stimulus, like your hand pulling away from a hot stove. Each plays a unique role, with varying levels of immediacy and reach. Understanding these types of control helps us appreciate the complexity of our body's homeostasis. Lastly, let's delve into the mechanisms that keep this control system in check. Picture a seesaw, continually balancing and adjusting to maintain stability. This is similar to negative feedback, which counteracts any deviation from the steady state. For example, if your body temperature rises, mechanisms are triggered to cool you down. Now, imagine a snowball rolling down a hill, growing larger and faster as it goes. This mirrors positive feedback, where an initial change triggers a response that amplifies the original alteration. Childbirth is a classic example, where contractions intensify until the baby is born. Finally, think of feed-forward control as planning for a predicted change. Just as you might pack an umbrella if you expect rain, your body can anticipate changes and prepare accordingly. For instance, your body begins producing digestive enzymes as soon as you start thinking about food. These feedback mechanisms are crucial to ensure our body functions optimally. To sum it up, we've explored homeostasis, the consequences of its failure, the integral components of a control system, various types of control, and feedback mechanisms. So, next time you're shivering in the cold but still feel warm inside, remember, that's homeostasis at work.